Today we shall learn about the decimal representation of rational and irrational numbers. Here, a decimal expansion are of three types. First one is terminating decimal expansion. That example is 3.4, 2.5, 6.25, etc. Second one is non-terminating repeating decimal expansion. That example is 2.666 and so on, and 3.6464 and so on. Then third one is non-terminating non-repeating decimal expansion. That is example is 6.321471923 and 4.62191147. Here, after this decimal, no digits are repeating here, so that it is called non-terminating and non-repeating decimal expansion. Here, after this decimal, the digit 6 is repeating, and after this decimal here 64 is repeating, so that it is called non-terminating and repeating decimal expansion. Here, after this decimal only 4 is there, and here after decimal only 5 is there, and here after this decimal only 2 digits are there, that is 2 and 5, so that this type of decimal expansion is called terminating decimal expansion. Here these two kinds of this decimal expansion, that is terminating decimal expansion and this non-terminating repeating decimal expansion, always represent irrational numbers. Here 3.4, this 3.4 can be expressed as 34 by 10, which can be expressed as 17 by 5, and it is there in the form of p by q. Then 2.5, this 2.5 can be expressed as 25 by 10, which can be expressed as 5 by 2, and this also it is there in the form of p by q. Then 6.25 can be expressed as 625 by 100, and it is can be expressed by 25 by 4, and this 25 by 4 can be expressed as 25 by 2 into 2, and this also there in the form of p by q. Then 0.3 can be expressed as 3 by 10, which can be expressed as 3 by 2 into 5, and this also there in the form of p by q. Therefore 3.4, 2.5, 6.25, 0.3, all these terminating decimal expansion can be expressed in the form of p by q, so that terminating decimal expansion always represent a rational number. Moreover, that here this q is a factor of 5, or q is a factor of 2, or q is a factor of both 2 and 5, so that if a rational number is having that q is a factor of 2, or either 2 or 5, or this both 2 and 5, then this type of rational numbers gives us a terminating decimal expansion. Now this non-terminating repeating decimal expansion also it represent a rational number. Here this 2.6661, this decimal expansion can be expressed as 8 by 3. This also they are in the form of p by q, and this one 3.646464 so on, and this decimal expansion also it can be expressed as 361 by 99, which can be expressed as 361 by 3 into 11, and then this also can be expressed in the form of p by q, so that therefore this non-terminating repeating decimal expansion also a rational number. Here we can conclude that here q is a factor of other than 3 or 5, q is a factor of other than 2 or 5. Therefore the rational numbers where this q is a factor of other than 2 and 5, then that type of rational numbers gives us non-terminating and repeating decimal expansion. Again, this third kind of decimal expansion, that is non-terminating and non-repeating decimal expansion, it is found as irrational number, and it is found in the form of root 2, root 3 and root 5. Okay students, I hope that you understand this that decimal representation of rational and irrational numbers. You remember this and you practice this. Okay students, thank you.